Okay, everyone, welcome to session 4P, IBM Hybrid Cloud-based mainframe DevOps CICD for development, testing, and production. I will hand over to Renee to do the presentation. Thank you very much.
Okay, thank you, Stuart. So I think we just have Steve here, so nobody else, if I'm correct.
That is at the moment, yeah. Oh, there's someone else coming now. I will disable the waiting room so that people can join if they come later. But of course, the value of this GSE one, Renee, is that every session is recorded, so GSE members will be able to catch up.
Okay, thank you. So first of all, GSE, thank you very much for having me, giving me the opportunity to do this presentation. So I have to go next page. Yes. So today I will talk about the IBM Hybrid Cloud, DevOps CICD for development and testing and production. What do we mean by this? I do not know if you are aware, but IBM has something what they call WASI. And WASI is a virtual mainframe environment that allows you to do development and testing in the cloud. You cannot run production, but it allows you to do development and testing in the cloud. And we have integrated our solution with WASI so that mainframe users can develop and test in the cloud and finally run production in on-premise or anywhere where the mainframe would reside. And as you can see, we are an IBM Silver partner. And myself, I'm René, and I'm the founder of ICANN. As I say to Stuart, I like interactive sessions, so please, if you have a question, you can always interrupt me. So we always say, let us make the mainframe great again. We think that the mainframe is still a great environment and will be here for many, many years. I think until last year, the year before, everybody thought mainframe will disappear. But we see that this has been changing dramatically the last 2 years. So people understand the value of the mainframe and understand also that it's not evident to move, let's say, mainframe loads to the cloud or even to Linux or Microsoft environments. Kobe. Kobe is the name of our solution. And Kobe, it's a framework. And on top of the framework, we have, let's say, an IBM Z solution, so a CICD solution for IBM Z. Although Kobe is a general purpose CICD solution that can manage any environment, you can do C development, Java, COBOL, anything. But today we will focus on, let's say, on our solution for IBM Z. To set the scene, we are always using, let's say, the Gartner DevOps representation. But for us, it's very important to stress that you are unique. And it's important that you can manage your process, you can satisfy your stakeholders, you can implement your tool chain, and you can orchestrate the way you want. And last but not least, you have your own culture. So all have their own culture, and it's very important to respect that. So this is maybe the most important slide, because this shows a possible architecture. As you can see at the bottom left, we have the developer that can use an Eclipse-based development environment. He can use Visual Studio, and you will see in the demo how to use Visual Studio. He can even use a 3270 screen if you would like to do so. The only thing we ask a developer to do is to version his code in a version control repository, be it Git or one of the Git, let's say, implementations or Subversion. At the same time, you can also see that we integrate with issue tracking systems like Jira, GitHub, and others. So when a developer commits his code, he can also enter the issue tracking numbers so that we can follow up during the life cycle what happened with that issue. Also, as part of the development environment, especially in the IBM context, a developer can use the dependency-based build. And based on the outcome of the dependency-based build, we can create what we call a package. And I will explain what we mean by a package. Same for the IBM Code Assistant for Z. So because using the IBM code for Z, in the first instance, you will restructure your COBOL. In a second instance, you can generate Java. This means that you will have COBOL code and Java code, and you will see that with Kobe, you can, let's say, build, compile both of these, and also deploy both of these together. So again, at the left, we have the developer, but important for us is the developer needs to commit his code in the version control repository. Once that is done, Kobe comes into place. So Kobe is a general framework for CI/CD, and you set up your projects in Kobe. The project is always linked to a Git or Subversion repository. And for each project, you can have one or more project streams. And a project stream is always linked to a branch. Second point, you can work with Kobe package-based or release-based. Package-based allows you to select these programs that you want to compile as part of your process, or when you work release-based, you will take the whole branch. Also, you can have multiple packages. So we can package multiple, let's say, one or more packages together to travel together to the lifecycle. How does it work? I will explain it in more detail later, but we get the code out of the version control repository, and then we see, is it COBOL, PL1, assembler, whatever. We will parse that code, and we will create a property file. Based on the property file, we can, or we will create in GCL. So we keep it, or we try to keep it simple. We think it's already the big step to go away from the pure mainframe to a web-based solution. So we thought it's important that we keep the comfort level for the people, and we generate the GCL from, let's say, based on the properties that we created from the source files. Having these GCLs, we will also use parameter files or property files to replace the values with, let's say, the standards of your company. By example, return codes, PDS, PDSE, naming conventions, compile programs you are using, etc. We will use these specific ones and will replace the parameters in the GCL model files with your own values. So once we have done that, we will build the code. The compile can happen again, as we are talking about an WASI environment virtually on that machine, or you can also do it on a Windows or a Linux machine or on the real mainframe. That's a choice that is open to you. Once the compile happens, we will store the results, the load modules, in a build archive. Again, build archive can be a simple file server, or you can also use something like Artifactory. And also as part of that build step, or what we call level request, we will also update the issue in by example, and I will show this in the demo in Jira. So in Jira, you will see this issue is part of this compile or this deploy. Once we have, let's say, the archive, we can take the next step and deploy to a test acceptance production environment. In Kobe, you can have as many test and production environments as you want, and these can be mandatory or optional. By example, if you have, let's say, a teaching learning environment, you can make this optional because you will not refresh it every time by example. And here we apply the same principles. Here we will, let's say, go to the build archive to collect the load module. We will again create the GCL. We will FTP, or using the REST API, communicate with the mainframe, or again with the WASI environment, to deploy to the load modules to the test or production environment. As part of the deploy phase, you can also run automated tests or any other action you would like to do. By example, DB2 bind or CICS update. And again, issues will also be updated. The deployment to a test and a production environment can happen approval based. So if there is no approval, you will not move to the next level. Also, what we also do, you can have, let's say, build number 1, 2, 3, 4, 5, by example, and build number 1 is in test. So next time you can redeploy that level, build 1 to test, or you can select 2, 3, 4, or 5. And if you selected, by example, 4, next time then you will have the ability to redeploy from 4 or choose 5, or let's say later on 6 or 7. And as you see at the bottom, what we do can be executed run on a Z system, on a Unix, Linux system, Windows, or in the cloud. And we do COBOL, PL1, Assembler, Java, let's say all languages that you can imagine on a mainframe. What is the objective? The objective is to have built and deploy processes that are standardized. So it's a standard, and the standard will be the standard as chosen by you. By example, they all sometimes ask us, how long does it take to do an implementation? And I always answer, there is a difference between the elapsed and CPU time. What do we mean by this? Elapsed, because it sometimes takes time for people to define how they want to work in the future. Because implementing a new system, say, okay, we want to take advantage or take the opportunity to redefine or to review the way how we work, how the way we develop and implement. But once we have made these choices, it goes very fast. By example, when we do a proof of concept, it never takes more than 2-3 days, and we ask you a number of programs and GCLs to compile and to deploy. And after 2-3 days, we can show you how it works in the COBie environment so that you can recognize your own programs, your own standards, and your own way of working. So these processes will be standardized, will be repeatable, fully documented, because we see more and more that people are asking for these systems for audit reasons. They want to know who changed what, when, and why. And also sustainable, because you also can grow in the future. Also important, we support waterfall and agile methodologies. And again, as I already explained, we can deploy to mainframe, Linux, cloud, or other environments. Bottom line, it's a cost-effective, risk-efficient. We do security checks, and we make sure that, let's say, the time to market is short. And as I already explained, we can integrate with WASI for development and test. And if you click on, let's say, the IBM WASI, you can find a data sheet on how that works. The architecture, so it's a web-based application, and the COBie runs on a Tomcat server. And you can use COBie using the web interface. You can use it through the REST API or through the command line. We have our own database, so it's a GDBC compliant database, can be Postgres, MySQL, Oracle DB2, SQL Server. And as already explained, we have a build archive, can be a simple file server or Artifactory or something equivalent. We integrate with several issue tracking systems. I think the most used one today is Jira, but also Team Foundation Server, GitHub, Micro Focus ALM, OpenText ALM, I should say today, and Azure. And from a version control perspective, we can work with Subversion, Git, Team Foundation, version control, still CVS, and also Azure with Git. The architecture itself, it's a server agent architecture. You can have one big server or a server with agents. And we have implementation where they say, well, we have an agent for development, one for test, one for production, or we have an agent per helper. So again, that's up to you how you would like to organize your architecture. Many times we get the question, well, why should we use COBie and not Jenkins? Because Jenkins is the open source product. So we took the liberty of, let's say, to see or what we think are the core differences between COBie and Jenkins. With COBie, we will enforce industry standards. In Jenkins, everything is possible, so there is no guidance. We think that COBie is very end-user friendly, and it does not require any CI/CD knowledge. COBie is well documented. By example, all documentation is online, so you can even today you can have a look at it if you would like to do so. And it's not like with Jenkins that it depends on the use plugin and the related documentation with that plugin. COBie is very easy to customize or to implement or to get up and running. It does not require programming skills, so you don't need to be a programmer. Of course, to be honest, when you do this for a mainframe, it's nice that you know something about the mainframe. I think if you don't know anything about the mainframe, it will not be easy to do that. Also, the version control integrations are default. Yeah. Also, the code tagging is included in the solution. Same for the integration with issue tracking like Jira, Foundation Server, and others. Also very important from an audit and compliance point of view, we have a unique workspace per build, automatic cleanup, and also, let's say, for the build archiving and the build history. We keep them even if you change the pipeline. The archives will be kept, what is not the case with, by example, Jenkins. We also have approval management and user notifications. Then we have, let's say, the ability to work with packages or with releases, and we have project dependencies. Also, let's say, regarding security, we integrate with the standard operation security systems, and you don't have to define your own security. Plus, very important, we have reusable, parameter-driven build and deploy phases or pipelines. And specifically in the context of Z systems, we have audit facilities and impact analysis for mainframe. So, Kobe comes with what we call phases. And a phase, what is a phase? A phase is nothing else than a package script that is predefined and that uses parameters. And the objective of a phase is to run the actions that will enable you to automate the CICD process, and it defines also the workflow. Also good to know is that the Kobe parameters can be defined in a hierarchical way. You can do this at an Kobe machine level, so then it will count for everywhere, or you can redefine it or override it at the build or deploy level, or you can also do this at, let's say, the phase level itself. So you have a 3 steps hierarchy. Phase itself, we have 3 types of phase. We have the core phases. See how I can get away with this, that you can see this. So the core phases, these are developed and maintained by us. By example, version control, repository retrieval, code tagging, issue tracking, integration is done by us and cannot be changed by users. Then we have the solution phases. These are for specific environments. They are developed by ourselves or by a partner. By example, the Z solution we have is developed by and maintained by ourselves and supported by ourselves. We also have a solution for Oracle Data Integrator that's done by a partner. And last but not least, we have custom phases. These are user defined. Again, these can be defined or developed by yourself. Can also be done by us or a partner, but these are not maintained by us. There is no support for these phases. So the architecture. 3 important components: the phases itself, the models, and the parameters. You will see that the models and parameters are in bold and the phases not. Why? Because you don't have to touch the phases. You take the phases as they are, but we will, let's say, complement the phases with the models. And we have a library with GCL cards. You can use these, or you can, let's say, extend that library, or you can change the models that are available to your own standards. Same for the properties. As explained, return codes, program used for compilation, PDS naming conventions. Here we see how, let's say, a script generate already explained, but I'll do it again. So from the version code repository, we get the sources, COBOL, PL, PL1, assembler, whatever. In the first step, we will parse the source, and then we see, is this COBOL, PL1, assembler, is it with CICS, DB2, whatever. And we put this in a property file. As a next step, the property file is used to see what GCL cards that we need to do a compile, to do a deploy, to do a test. Once we have collected the required models, we have the full GCL. And as a last step, we will use the resource files, and we have a separate application, the Kobe resource editor, where you can define these resource files, and then the GCL cards parameters are replaced by the resource files defined by you. Here we have an example for a pre-compiled CICS. So we have the model file left, then we have, let's say, the resource file left, sorry, and at the right we have the model file with the parameters. And at the bottom you see, let's say, the generate GCL, where the parameters are replaced by the values from the resource file. Some specific features. As already explained, we can work package-based. So when you have very large projects, it's better to have, let's say, a small portion that you can use to do a compile. Same for the project dependencies. So the project dependencies allow you to, by example, if I can give the example of the code assistant, when you have, let's say, COBOL programs and you have Java programs, well, this allows that the COBOL programs to work in their corner to create their package. Same for the Java programmers, they work in their corner, create their programs. But through the project dependency, the main project will take into account the results of the dependent project. Even if they work totally independent from each other, we will see that these both travel together in the life cycle. Also have some utilities because one of, let's say, the things that we see is that people want to move from the legacy SCM systems like Endeavor, ISPW, Changeman to a web-based, Git-based CI/CD solution. So for Changeman, we can, let's say, using the reverse delta technology, we can use this to populate a Git repository starting from a Changeman implementation. Same for Panvalet. We can also, let's say, copy Panvalet members from a PDS to Git or Subversion. Same for standard PDSs and sequential files. And last but not least, we can also go from Git Subversion to a PDS for further working. We also have impact analysis. So in impact analysis, we have, let's say, a relational table where we keep these relations between, by example, a COBOL program and copybooks. Same for PL1 assembler. Yeah? You can also see what programs use subroutine or whereas subroutine is used. Same for GCL or PROC, and the data sets names that are used in GCLs or PROCs. Audit function also. Here you can see, by example, copybooks that have been changed after source program has been compiled. So do you need to recompile, yes or not? And there's also hierarchy and audit. So you can say in this we have return codes, and you can say, okay, return code 4, we continue, return code 8, 12, or 16, we stop, and you need to fix that, what has been found in the audit. Plus we also have, let's say, the audit, the auto resolve function, if needed or if applicable. Some use cases. So the first use case is a customer that had two sites with Visam, Assembler, and Panvalet and Panapt for SCM. So Panvalet was used for the source code management, Panapt was used for the CI/CD part. Today, they migrated all their source codes from Panvalet to Git, and they fully replaced Panapt with Kobe. Today, they are managing two sites, one US-based, one Euro-based. And important, this took less than 6 months from decision to the implementation. And this has been done totally virtually. So this was in the late COVID days. So we did this virtual using Teams sessions. Second use case, one site with DB2, Visam, COBOL, CICS data state, Changeman. And they wanted to replace Changeman. Plus, they also wanted to manage not only the Z system, but also they wanted to migrate and manage the Linux environment with Oracle instead of DB2 and with Tuxedo instead of CICS. Today, they have one solution, Kobe, that manages both environments, plus also the Windows environments. And let's say the dependency management is used to manage the mainframe and Linux dependencies. So customer quote, the customer wanted to have one product that managed the whole build and deploy process for all the platforms. Yeah. So they replaced Changeman with Kobe and they saved more than 2/3 on software maintenance costs, also reduced the number of people in charge of monitoring the change management activities, and they even could, let's say, they didn't need an external consultant anymore to do the work. Third use case was let's say, a customer that result of a merger. Two sites, one with IDMS, Ads Online, COBOL, and a homemade SCM system, and a second one with Datacom PL1 Changeman. Today, they have one solution, Subversion-based, with COBOL that manages both IDMS, Ads Online, COBOL, Datacom PL1, and that introduced a lot of reuse, what they didn't have before. So the customer quotes, Kobe allowed us to modernize our mainframe development as we wanted to use an Eclipse-based development environment and needed to have a compatible lifecycle management solution to replace our current mainframe-only version control software. And important for them, Kobe allowed us to interface with the mainframe as extensive customization possibilities. So what they did, they used also Kobe to do what I would call trial and error, to try several possible implementations to finally, say, make the choice that they wanted to work with. So next, I will give you a live demo with Kobe for Z and also the Z resource editor. We also have a document that explains how you can set up Kobe for ZOS. And if you click on the link, you will find this. So I don't know if in the meantime there are any questions.
There are no questions in the chat, Rene.
Okay, thank you. So this is my virtual machine. And I have here, we'll start with VS Code. So I have here, let's say, my folder with my demo projects. And I have here a number of batch programs. I'll make some very stupid, simple changes, but that you understand the, let's say, the mechanics of it. Save this second program. Also make a change. Save it here. CSS program. Save change. So I made 3 changes. And again, the developer here, as I explained, can use, by example, dependency-based build, DBB. We can use the result of DBB to create a package. Or you can use the code assistant for Z, and then you will put your restructured COBOL programs into Git, and or let's say your Java programs into Git, and then Kobe will just take over to do the compile and the build. So I have 3 changes. So now I have to here to commit and push my changes. I will put in some issues that I solved, and then I will commit and push to my Git repository. So this is what a developer has to do. And once this is done, Kobe takes care of all the rest. Also, I will show you the Kobe web interface, but you can use the REST API, or you can use the command line. And by example, from within VS Code or Eclipse, the IDZ from IBM, you can launch also a build or compile. So here I have Kobe. Log in. So the first thing you see is what we call the desktop. And here I have a number of projects or packages defined. You can see with assembler, COBOL, PL1, and here I have one package. And if I want to see the my package content, and this one. This is the content. So the copybook and the 3 sources that I edited and changed. But here I have, let's say, the full branch. And eventually, if I would like to do so, I can add other, let's say, or I can also delete or not, let's say, keep in the package certain programs. And I can also start from my package itself. I can start my build or go to test production. I will go back to my desktop. And here I say, okay, I want to do a build. I always need to give a description. And then I can create, and I will see my build or compile is up and running. So while this is running, because it will take about 2 minutes, I think, I can show you the what we call global admin. So before you can start working with Kobe, you need to do some activities. So by example, the global admin and the project admin. Global admin, you have your version control repositories. I will show you the one that we have. So here I have my Git repository. So all you need to do is to define your connection, so the command path, cache location, URL, and password, and of course repeat your password. Then when you test your connection, you see it works. So that's the only thing that you need to do. And here you can also see the projects that are currently connected to that Git repository. Same for issue tracking. Here we have, let's say, an implementation with Git. Again, I can test it. Works. Or I can also show you, let's say, the different possibilities we have. So we have, let's say, a generic plugin that you can use for any issue tracking system. Or we have, let's say, the Micro Focus, the OpenText. We have GitHub, Jira, Team Foundation server that you can define. Also, as I explained, we have, let's say, here on the machine parameters. So here you can define the locations. And once you have, let's say, defined it here, it will be used overall Kobe. But if you would like to do so, you can override it. I will show this later in your project at the build or deployment level, or at the actual phase level also. And then you have here the phases. And here you see, sorry, name. I'll give you one related to the mainframe. Compilation by example. So you can see here the parameters that you need to manage, or that are given by default. So you can see here where this phase is used. So I'll go back to my desktop. See, it's still running. What we are doing now, a build and deploy, we call this a level request. So you see now it's running, but you will see you have a summary, and you can see it's built based on the latest code. Yeah, and it has been requested by myself. And then we have the phase logs that have the detail of every action that has been taken. By example, when I look at my build step, you see here everything that that happened. So by example, the compilation, you can see the different steps that it took. Yeah. Then we see the results. And again, you can define this. By example, we have here the copybooks, the listing, load modules, load CICS, the properties that we use to create our G cells, and then the sources. But you can customize what you would like to have in the archive. Well, no approvals here with the build. Issues. I can, by example, suppose I did forget one, I can add one. 3. Yeah. Create. I can sync this to get up the description. And then if I would like to have a look at one of these, I open it, I open my Jira, and you will see that here I have a link to from within Jira, go to Kobe to see what happened in this specific level request. Yeah. Here again, the sources that I used, modifications. You will see that he says, well, these programs have been changed. I don't have dependencies here, so I cannot show this here. So once this, let's say, the build has been done, the result has been archived, I can do the next step, which is deploy to test. As explained, I can redeploy what is currently in test, or I can take what I just let's say, compiled. So I do create, and again, I will have the same, I will have here my deployment, and you will have the same informations available, phase logs, no results, of course, because I don't do an compile, approvals, if any, issues, and the sources that are used. But while this is running, I will show you the project admin. So I feel my project with my overview. And the first thing that we have is here what we call the project stream. As I explained, the project stream is linked to a branch. Yeah. So here we have just one branch. that I've defined. I have no dependencies, but here is the location where you define the dependencies. I can define my life cycles. I can have several life cycles. You have one base life cycle where I just do a build, deploy to test and to production. And you can see here that we have the notification. You can say notification never, or when a build or compile was successful, or when a build failed. Yeah? You can also have a pre-notify, and you can also have the pre and the post approval. So I will show the approval in when I move to production. And then we have the levels. So we have then a build, test, production level. So one for each, and the environments for build and deploy. Here, by example, when I look at the build parameters, well, you will not, but by example, I think that I defined the directory for the models at machine level, but I overwrite it here and to say that my build models are in a different place as defined at the machine level. Same for deploy environments, but we'll have a look at the overview. Because here, by example, you see the phases that we run. By example, to show you the debugger. You can see here that I can, as a type, I can have event date, smart test, expeditor, easy retrieve, IBM DF. But again, I can extend this, or I can write my own phase to enter phases. What I also can do, go back to phase overview. I can insert a new phase because I want to extend my pipeline. I have this here. I was looking for SonarQube, but I don't have it here. But let's say I take just one for sake of demo. Take this one, and then I can insert. I have to say where I want to insert it. After this, and next phase on error, cleanup, and then I will not do it for sake of. But normally it's let's say this phase will be inserted, and then your let's say you will run this additional phase. So I go back to my desktop. I think my deployment to test will have happened. Yeah, and look at my phase logs. It's in deployment. And here I can see, let's say, the libraries that I used to do the deployment. So next, we deploy to production. Okay. Then again, I can choose the recent one or the one that is currently in. I take the latest one. And now normally, I receive an email, but just here to keep it short, you see here, waiting pre-approval. Then I open my outstanding approvals. And here I can reject or approve, I say, for demo. And now it will deploy, but before, I wanted to show here that, sorry, to show here that there is nothing in the library. I hope I'm fast enough. Here. Stretch. This one. When you give a demo, it will never work, of course. Okay, I will see this later because I wanted to show also something else. Here we have, let's say, the resource configurator. And here we have, let's say, the different parameters, but I will start with the models to show what the COBOL CCL model. Here you can see, let's say, the parameters by example, or the program condition codes are all defined, let's say, in a different place. And where do we do this? We do this here in what we call the language ZOS properties. So my example for COBOL, you can see here for the copy step, EV2, Datacom, service CICS, and compilation is what we just showed. So you can see here that's the model file. And if you would like to use another one, just replace this and you define the one that you want. Main program step, you can change this parameters. It's up to you to define these, etc., etc. So you can fully customize this to your own needs or wishes. And same for, let's say, the Z environments, build, compile properties, also prefix that you have the qualifiers for your PDSs, etc., are all defined here in the resource configurator. So I'm going back to scene here. Okay, so deployment happened successfully. And again, you can see here on the phase logs, I can see the deployment. These are normally yeah. Okay, now see you accept one, accept two here. Same for CICS. And here I see my program, which was not there the first time. So this, let's say, in a short overview on how COBie works and what COBie can do. So I don't know if there are any questions.
No questions, Renee.
Okay, that's it. I think if there are no questions, then I would like to thank you very much for being here. I hope it was useful.
No, okay, Renee.
Well, thank you very much, gentlemen.
That's a wrap. Okay.
Yeah. Have a good rest of the day and conference. Thank you very much.
Yeah. Bye.
Bye.